On the next slide, so the problem is given here. This is the current source I1, this is I2, the resistance is R1, R2, R3. So here we consider two node you can find in this figure. The first node is V1 and the second node is V2. Okay, so apply at node 1 apply KCL. So we have to apply KCL for this node analysis and KVL for mesh analysis. So at node 1 apply KCL, we get I, yes, this I is equals to the, this is the incoming current of this particular node V1 and the outgoing current is I1, I2 and capital I2. So you can write that capital I1, this one is equals to small I1 plus small I2 plus capital I2. So capital I1 equals to V1 by R1. Yes, small I1 equals to V1 by R1. Then I2, V1, I2. What is I2? The current on this branch. So V1 minus V2 by R2, and the current is here I, capital I2 is the current source. So no problem with this. At node 2, now we are going to apply the KCL at node 2. So what will happen here? Look, at node 2, apply KCL capital I2 plus node 2. This is node 2. So here I3 is the outgoing current and capital I2 and small I2 is the incoming current. So the outgoing current is equal to incoming current. That is the KCL. So capital I2 plus small I2. This one and this one is equals to I3. So I2 will be equals to minus I2 plus I3. So I2 is equals to minus V1 minus V2 by R2 plus V2 by R3. So here minus I2 is equals to V1 minus V1 minus V2 minus V1 minus V2 by R2 plus V1 V2 by R3. So here if I1, I2, V1, V2, R1, R2 is known, then we calculate small I1, I2 and I3. So in this way, we can apply the node analysis here in this problem. So this is the process. So a problem is given in the network, find Vx using nodal analysis. So applying KCL at node 1 and 2. So we are applying KCL at node 1 and 2. This is the first node, the V1, the second node is V2. So V1 minus 20, this is V1 minus 20 is the voltage difference. So we have to find the current of each branch. So V1 minus V2 by resistance is 4, this is the current. Then the current along J4 ohms, V1 by J4, then V1 minus V2 by 4. So this is the node voltage, node 1, the applying KCL at V1, then V2 minus V2 at node 2, V2 minus V1 by 4, V2 minus V1 by 4, then V1 by J4. So this is the modified form of the equation. So in this way, V2 by 4 plus J4. So V2 by 4 plus J4, V2 by 4 plus J4, 4 plus J4 in this area. V1 by J4, V1 by J4. So in this way, we can find the value of V2, that is 4.436 angle 83.64, and the I value is already calculated here. So Vx value we can find with the calculation. So in this way, we can apply the node voltage here in this equation. Now, so here we have to find the, actually we have to find the branch current, all the branch current of the given network. So and then we need to apply the KCL, whether the incoming, you know that incoming current is equals to the outgoing current, or the summation of all incoming current outgoing current equals to 0. So this is KCL. So current, now you know that current is I equals to V by R. So find the voltage difference of each branch, then divide it by R. So in this way, calculate, we have to calculate the voltage. Now star and delta transformation, you know that star and delta transformation is a very important part for this circuit analysis. We can now solve simple series, parallel and bridge type resistive network using Kirchhoff's current law, mesh current analysis or node voltage analysis techniques, but in a balanced three-phase circuit, we can use different mathematical techniques to simplify the analysis of the circuit. Now in the second, the star connected network is transformed into an equivalent delta circuit and also to convert a delta into an equivalent star circuit using the transformation process. Number three, this process allows us to produce a mathematical relationship between the various registers, giving us a star delta transformation as well as the delta star transformation. So here firstly, we are considering the delta star transformation. So for delta star transformation, so delta star transformation here, the replacement of delta or mesh by equivalent star connection is known as delta star transformation. So it is the replacement of delta or mesh by equivalent star connection is known as delta star transformation. The two connections are equivalent or identical to each other if the impedance is measured between any two pair. So here the resistance between the terminal A and B will be resistance between terminal A and B will be for here we are just converting delta to star. So RAB, that is the equivalent resistance between A and B terminal, that is R1 parallel R2 plus R3. So R1 is R2 and R3 connected in series. So R1 is connected with R2 plus R3 parallelly. So it is R1 into R2 plus R3 divided by R1 plus R2 plus R3. So RAB equals to RA plus RB. So this is for star connection. Now if we measure the resistance value between point A and B, we'll get now since two systems are identical, resistance measured between terminal A and B in both systems must be equal. So here just add RA plus RB, that is 1 and 2 equations. Similarly, resistance between B and C terminal will be B and C being equal to the two systems, that RB plus RC. So the equation will be like this, like equation number 2. And resistance between point C and A being equal to two systems, RC plus RA. So like the previous slide, we can make this three equation. Now adding equation 1 to 3, we get 2 into RA plus RB plus RC, that is equals to 2 into R1 R2 plus R2 plus into R3 plus R3 plus R1 divided by R1 plus R2 plus R3, and then RA plus RB plus RC will be equals to R1 R2 plus R2 R3 plus R3 R4 divided R3 R1 divided by R1 plus R2 plus R3. Now subtracting equation 1, 2 and 3 from equation 4, we get, yes, so what we get by subtracting 1, 2 and 3, we get equation number 4. We get that RA equals to R3 R1 divided by R1 plus R2 plus R3. RB equals to R1 plus R2 divided by R1 plus R2 plus R3. So RC equals to R2 R3 divided by R1 plus R2 plus R3. So delta to star and star to delta conversion, we can make both. So when this is the equation for star to delta conversion, and the previous one was delta to star conversion. So here I am going to discuss about the star to delta conversion. For star delta conversion, we just multiply equation 5, 6, 7, 5 and 6, and 6 and 7, and 7 and 5. That is by doing the multiplication of 5 and 6 and add it with 6 and 7 with the multiplication of 6 and 7, and then add with this with the multiplication of 7 and 5. We get this equation. So RA RB plus RB RC plus RC RA. So after multiplying, we'll get R1 R2 square, R3 plus R1 R2 R3 square plus R1 square R2 R3 divided by R1 plus R2 plus R3 whole square. Now R1, the common part of here, common part is R1 R2 R3 into R1 plus R2 plus R3 divided by R1 plus R2 plus R3 whole square. So this will be R1 R2 R3 by R1 plus R2 plus R3, because R1 equals to R3 R1 divided by R1 plus R2 R3 plus R2 plus R3. RB equals to R1 R2 divided by R1 plus R2 plus R3. RC equals to R2 into R3 divided by R1 plus R2 plus R3. So equation number 8 will get from here. So first we need to multiply 5 and 6, then multiply 6 and 7, then multiply 7 and 5, and add these 3 multiplication. Then after modifying, we'll get this value. Now dividing equation 8 by equation 5, again we have to divide the equation with equation 5, 6 and 7 separately. We get R3 equals to RA RB plus RB RC plus RC RA divided by RA. R1 equals to RA RB plus RB RC plus RC RA divided by RB, and R2 equals to RA RB plus RB RC plus RC RA by RC. So it's a very simple and easy process. Very easily you can calculate the value. Now, so what is the conclusion we can take from here? The conclusion is that for the star delta, and this is the delta star, the first one was delta star conversion. So from delta star conversion, we find that the value of RA equals to R3 R1. So by R1 plus R2 plus R3, the value of RB R1 R2 by R1 plus R2 plus R3, and RC equals to R2 R3. No, I think okay. So this is the part now. RA equals to, this will be 2 3. No, 1 2 3. RC 2 3. Okay, fine. So these are the equation we find from delta star conversion, and here this is the star delta conversion. So it's the easiest way. Now a problem is given, so solve it for the better understanding of the subject. Now this is the reference I used to make this PowerPoint presentation. The textbook of Sudhakar, Circuit and Networks Analysis and Synthesis, is a very good one. The book of D. Roy, Networks and Systems, New Age International Publications, and then some other books, OFF, Network Analysis and Synthesis, John Williamson's the book. It's a very good book for this subject also. So let me talk about the whole lecture of today's. The first I talk about the mesh analysis, and I think you have learned this, the mesh analysis, that how to form the mesh equation. That we know that using KVL the mesh analysis is solved. Then we solve a problem. So this is the problem. So using the matrix we solve the problem. We find the value of the currents. And then the nodal analysis. The nodal analysis is basically depending on the KCL, the Kirchhoff voltage current law. So here we find the sign voltage V1, V2, V3. So we need to consider for loop analysis, we have to consider the loop and the direction should be as per the user. For node analysis, we need to consider the node. Okay, so it's like V1, V2, and V n minus 1. Then we solve a problem of the node analysis problem, which is given in here. So the problem of node analysis is very crucial type, and here we need to apply the KCL. So the process is first consider a node, then consider the voltage of that node, then find that how many branches are connected with it, then find individually branch current, and then check whether what how many current is coming and how many current is going from that particular node. So summation of all the incoming and outgoing current should be equal to 0. So in this way we can find the voltage of that particular node. Okay, so then we move to the star delta and delta star transformation. So star delta and delta star transformation sometimes helps us to solve the difficult circuit in easiest manner. So it is actually a very important part. Uh, so you need to understand this one. You have to clear your concept regarding this. So star delta transformation. So first one was delta star transformation, and here the value was we find the values. We consider a delta network, and then we find the equivalent resistance across A, B, BC, and CA terminal. And similarly, we find the same value for the star network, and then we add it. After adding, we just sum all the equation, and then finally we get the equation of RA-RB-RC. That is actually RA-RB-RC is the resistance of the star network, and the right hand side there are the values of the delta network. So putting the value of the delta network, we can easily find the star network value. So now the star to delta conversion. So star delta conversion, the previous equation, equation 5, 6, 7, we have to consider all the three equations. Then we need to multiply cyclic symmetric order, the 5 and 6, then 6 and 7, the 7 and 5, and then we need to add that. After adding, we'll get equation. Then using the simple mathematics, we need to divide the final equation with the individual equation of RA-RB-RC. Then after doing that, we can measure the value of R1, R2, and R3. So this is the process. It's a very simple process, but practice is very much required for this. So you all have to go through these topics very much so that you can solve the problem, different types of problem. Now finally I'm giving you a star network, and solve it, try to solve it, consider it as an assignment. So if any doubt, any problem is there, let me know so that I can solve your problem. very easily. Thank you all. Thanks for watching the video. Goodbye.